Don't you think it is amazing how the human body is formed from such small particles? Have you ever wondered what these particles are? They are called atoms. I would not have been standing here in front of you if these atoms remained as individual species. How do these atoms come together to form something as gigantic as a human being? The story behind this is very fascinating. You try to obtain good marks in exams, build friendships, and plan an exciting career to attain some stability in life. Atoms try to attain stability too. How do they do it? They do not have as many desires as we have. They either hunt for electrons or give away their own electrons. Most atoms become stable by just reaching the octet state.
When an atom obtains 8 electrons in its outermost shell or the valence shell, it is said to have achieved an octet.
Few atoms like neon, argon, krypton, xenon, and radon have 8 electrons in their outermost shell. These atoms are stable and are called inert gases. However, all other elements have less than 8 electrons in their valence shell. In the periodic table, group 1 elements, such as sodium, have 1 electron in their valence shell. Group 2 elements, such as magnesium, have 2 electrons. Group 13 elements, such as aluminium, have 3 electrons. Group 16 elements, such as oxygen, have 6 electrons. Group 17 elements, such as chlorine, have 7 electrons. So, how do these atoms attain the stable octet state? Atoms are smart. They give up the excess electrons to the atoms that require electrons and thus resolve the electron crunch. Sodium atom has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 protons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 electrons, and an electronic configuration of 2, 8, 1 in its neutral state, whereas neutral chlorine has 17 protons, 17 electrons, and an electronic configuration of 2, 8, 7. Both the atoms are unhappy, as neither of them have 8 electrons in their outermost shell. The sodium atom has 1 electron in its valence shell. It is eager to give up its electron to attain the stable octet state with the electronic configuration of 2, 8. The chlorine atom, on the other hand, with 1 electron less in its valence shell, is desperately looking for an electron to attain the stable octet state. Hence, it easily accepts an electron to attain an electronic configuration of 2, 8, 8, which is a stable octet state. After attaining the stable octet state, both of these atoms are happy. They are now no longer in their neutral state, but exist as ions. Sodium now has 11 protons and 10 electrons and has a positive charge. A positively charged ion is called a cation. Chlorine, after gaining an electron, has 17 protons and 18 electrons and is negatively charged. A negatively charged ion is called an anion. According to the law of nature, oppositely charged species always attract each other. So, sodium ion with a positive charge and the negative chloride ion attract each other very strongly by electrostatic forces of attraction to form sodium chloride, also known as table salt. This electrostatic force of attraction between a cation and an anion is called an ionic bond. Don't you think it is amazing that a compound called sodium chloride, which is an essential ingredient in food, is formed when a highly excited sodium atom comes in contact with a poisonous chlorine gas? Not just sodium chloride, there are other compounds like magnesium oxide, which is formed when magnesium and oxygen atoms are brought close to each other. Calcium chloride, another example, is formed when calcium atom gives one electron to one chlorine atom and the other electron to the other chlorine atom. So far we have studied bond formation between atoms, where one atom is willing to give an electron and the other atom is ready to accept an electron. What if both the atoms are neither willing to give up nor accept an electron? Suppose two chlorine atoms come close to each other. A chlorine atom has 7 electrons in its outermost shell. So, both need an extra electron to attain the state of octet. This chlorine atom does not want to give up its electron. Neither does this, as they both need one more electron to attain stability. They are both very upset. So how do they attain the stable state if there are no other atoms in their vicinity to gain an electron from? Suppose you have 2 donuts and your friend has 2 chocolates. Since both of you love donuts as well as chocolates, we would share it, right? Similarly, 2 chlorine atoms decide to share the electrons amongst themselves. On doing so, the chlorine atom here has 1, 2, 3, 4, 5, 6, 7, 8 electrons in its outermost shell. And this chlorine atom too has 1, 2, 3, 4, 5, 6, 7, 8 electrons in its valence shell. Both the chlorine atoms are now happy, as their outermost shells are completely filled. When 2 chlorine atoms share their electrons, another type of bond called covalent bond is formed.
A covalent bond is a bond formed between 2 atoms with the sharing of electrons.
Similarly, when 2 oxygen atoms, each with 6 electrons in their valence shell, come close to each other, they share their electrons to form covalent bonds between them. Fluorine, bromine, carbon dioxide, and nitrogen are examples of molecules whose atoms are held together by covalent bonds. Just as different people want different things in life, different atoms have different needs. Some atoms like hydrogen, which has 1 electron in its outermost shell, beryllium, which has 2, lithium, which has 1, are satisfied with just 2 electrons in their outermost shell, which is also the electronic configuration of another inert gas, helium. This is called the duplet state. These atoms are happy, far away from their octet state. For instance, if we have 2 hydrogen atoms close to each other, and each hydrogen atom has only 1 electron in its outermost shell, both the hydrogen atoms can share their electrons to reach their stable duplet state. Water, the most abundant resource on Earth, consists of hydrogen and oxygen. Hydrogen requires 2 electrons and oxygen requires 8 electrons to reach the stable octet state. Oxygen, with 6 electrons in its outermost shell, is short of 2 electrons, while hydrogen has 1 electron in its valence shell. So how does oxygen satisfy its needs? If 2 hydrogen atoms come close, then the issue is sorted. Oxygen shares 1 electron with this hydrogen here and another electron with the hydrogen atom here. This way, oxygen atom has 8 electrons in its valence shell and both the hydrogen atoms have 2 electrons in their valence shells. Two covalent bonds are thus formed in a water molecule. It is very interesting to think of how all the compounds that have immense importance in our daily lives are formed as a result of bond formation between the constituent atoms. Depending on the way the atoms combine, different types of bonds are formed. Ionic and covalent bonds are the 2 types of bonds that we have dealt with here.